Okay, today's lesson, 13.5, is found on textbook page 598, if you're following along in your textbook. And yesterday we learned about slope-intercept form of a line, which is y equals mx plus b, where m is the slope and b is the y-intercept. Today we're talking about a different form. This is called standard form. I don't know why it's called standard form, because usually y equals mx plus b is the one people use. We should call that one standard form, but I didn't get to make the rules. So this is what standard form is. ax plus by equals c. Well, you see the x and the y are still in here, kind of like y equals mx plus b. They both have the x and the y. And here it just says a and b cannot be 0. Okay, so we cannot, a and b are not both 0. So we cannot have 0 for both of those at the same time. And so when we find a equation in this form, we can still graph it. The first way they're going to tell us to graph it is take the equation. In example 1, they give us this equation right here. Negative 2x plus 3y equals negative 6. So now you can see that's in standard form because it does follow this form. Some constant times x, in this case it's negative 2, plus some constant times y, in this case it's positive 3, equals another constant, negative 6. And a and b are not both 0. So it does follow standard form. And when they want us to graph it this time, their first thing is to take that equation and make it slope-intercept form. So remember slope-intercept form. I'll put the two forms up here. Standard, which is what they just gave us, is ax plus by equals c. Slope-intercept is y equals mx plus b. So they want us to take this form and turn it into that form. So let's see what that'll look like, which means we need to solve for y. The first thing we're going to do is add 2x to both sides. So we'll add 2x, we'll add 2x. And that makes this side 3y equals, now remember the x term comes first, so 2x minus 6. Well, that is starting to look a lot like our slope-intercept form, but we're not done because y is not by itself yet. So we will divide by 3, and we divide by 3. Dividing this whole thing by 3 is the same as dividing each of these things by 3. So when we divide this side by 3, 2x divided by 3, we get 2/3 x, 2 over 3. And then minus, and then 6 divided by 3 is 2. Well, there we have slope-intercept form. Y equals m, our slope, 2/3, x, plus b, and our b would be negative 2, which means this line will cross the y-axis at negative 2, and it'll go up 2 over 3, up 2 over 3 for the slope. So let's look at what they've graphed for us. Here's their graph. Oh, first they turned it into y equals mx plus b. Got what we got. Good for them. And it crosses the y-axis at negative 2. And then we can graph it by going up 2 over 3. Put in another dot. We could go up 2 over 3 again. If the graph extended over here, we could put another dot. Okay, so that's how they graphed it. They put it in y-intercept form. Slope-intercept form. Sorry, slope-intercept form. And then for the on your owns down here, we're not going to graph them because you probably don't have graph paper at home. However, we are going to turn these 4 equations into slope-intercept form. So for number 1, they gave us x plus y equals negative 2. And to put that in slope-intercept form, we just subtract x from both sides and get y equals negative x minus 2. And negative x is the same as negative 1x. Remember, because I want to see the slope in there, I actually am going to put the negative 1x. There we go. The slope is negative 1. And the y-intercept is negative 2. For the second problem, not quite as simple as that, we had negative 1/2 x plus 2y equals 6. First thing we'll do is add 1/2 x to both sides. That leaves us with 2y on this side and 1/2 x plus 6. Now we do have to divide by 2. Divide by 2. And y equals, well, 1/2 divided by 2. 1/2 divided by 2 is the same as divided by 2 over 1, which is 1/2 times 1/2, 1/4. Or you could think a half of a pizza divided by 2 people, each of them is going to get a fourth. Either way, you've got 1/4 x left here, and 6 divided by 2 is 3. So y equals 1/4 x plus 3. What's the slope of that? 1 over 4, of course. What's the y-intercept? 3, which means it crosses the y-axis at y equals 3. For number 3, negative 2 over 3x plus y equals 0. We'll add 2/3 x to both sides. And we're left with y equals 2/3 x. And we're all done. There is no y-intercept. It looks like here. Really, that means the y-intercept is 0, which means it crosses the y-axis at the origin. And the slope is, of course, 2/3. And then we have number 4. They give us 2x plus y equals 5. We'll subtract 2x from both sides and be left with y equals negative 2x plus 5. Crosses the y-axis at 5, and it's got a slope of negative 2. Well, the next thing they want to show us in example 2 is we can graph right from the standard form. We can use the standard form to graph that line. We don't have to turn it into slope-intercept form. What we do is we take this standard form, so they gave us x plus 3y equals negative 3. And what we're going to do is using the intercepts, we will be able to graph this line. And remember, at the x-intercept, or well, let's start with the y-intercept. The y-intercept, x is 0. It's where it crosses the y-axis when x is 0. So let's put 0 in for x. If we do put 0 in for x, that becomes 0 plus 3y equals negative 3. Of course, that just goes away, so divide both sides by 3, and y equals negative 1, which means when we put 0 in for x, y is negative 1. And there is a point that we can graph. It's our y-intercept. We can do the same thing to find the x-intercept, except we put 0 in for the y value. So we'll start with that first equation again. And this time, we'll put 0 in for y, which makes this x plus 3 times 0 equals negative 3. Of course, putting the 0 in for the y just makes that y term disappear. And we're left with just x equals negative 3, no more solving needed. So when y is 0, x is negative 3. That's our x-intercept. So we can take those 2 points now, and we go to the graph, and we can plot the 2 points that we just found. We can plot 0, negative 1, right here, 0, negative 1, our y-intercept, and we can graph negative 3, 0, our x-intercept. And once we have those 2 points, we can draw a line through those 2 points. So we can use our standard form and find the 2 intercepts, and then we can draw our line. If we wanted to, we could have turned that into slope-intercept form, and we would have been able to have that same graph anyway, but they wanted us to do it with the intercepts. So now on the on your own down here, We won't graph these, of course, but what we will do is we will turn those, or find the intercepts with the on your owns down here. So for number 5, they give us the standard form 2x minus y equals 8. And if we put 0 in for x, so here's going to be one of our intercepts will be this, and the other intercept will be this, okay? So if we put 0 in for x, if that means that goes away, we're left with negative y equals 8. So if negative y equals 8, that means we could multiply both sides by negative 1, y equals negative 8. Or if we put 0 in for y, then this term goes away, and we're left with 2x equals 8. And if 2x equals 8, then x equals 4. So there's our two intercepts, our y-intercept and our x-intercept. We plot those 2 points, and we draw the line through them. For number 6, they give us x plus 3y equals 6. We'll come up with our two intercepts. One has a 0 for the first, and one has a 0 for the second coordinate. So if we put 0 in for x, when x is 0, that means that goes away. 3y equals 6. Y must be 2. If we put 0 in for y, that goes away, and it just says x equals 6. Thank you very much. So here's our y-intercept, our x-intercept. We put dots or points at those 2 places, draw a line through them. So that's how we can graph straight from the standard form. Here are a couple of the problems, or a few of the problems I should say, out of the book. I do like these match the equations with the graph. So let's look at this first one here, and we'll just look for the intercepts to see if we have them. So if we put 0 in for x, that would make this negative 12y equals 60. So negative 12 times what equals 60? Negative 5. So when x is 0, y is not 5, because negative 12 times 5 would be negative 60. So that one doesn't work. Actually, it should be negative 12 times negative 5. So when x is 0, y is negative 5. Oh, this one looks more realistic over here. So we have to have 0, negative 5. Both of these graphs have that. And then if we put 0 in for our y term, we have 15x equals 60. So obviously x would have to be 4. So it would be 4, 0. 4, 0 right here. So 0, negative 5, 4, 0. That graph right there, that line, represents that equation. 11 is B. So 11 is B. Should erase out of my book. What a bad example I am. Number 12. If we put 0 in for y, that would mean 5x equals 20. 5 times 4 is 20. So when y is 0, x is 4. So 4, 0 we need. Oh, both of these have 4, 0. If we put 0 in for our x term, 4y equals 20. So y must be 5. So 0, 5, and 4, 0. Okay, so 12 goes with A. 11 was B, and 12 was A. So 11 was B, and 12 was A. And hopefully 13 is C, but we'll double check. Over here, if I put 0 in for my x term, that means the x term goes away. 8y equals negative 40. 8 times negative 5 is negative 40, so 0, negative 5, yep, that works. And if we take out our y term, if we make y 0, then our x-intercept, 10 times negative 4 is negative 40. So negative 4, 0. So, yep, 13 is C. Gives us that graph right there. Excellent. So now go and do the journal page that goes along with this for lesson 13.5.